So very good morning guys. So in this session we will see how we're going to delete the first node and last node in circular linked list. Fine. So let's suppose this is my circular linked list having two-part info and link. Info contains data, link part contains the address of next node, and then there is a first pointer which always points to the very first node of a linked list. So first we will try to write a program of deletion of the first node. I want to delete this. So let's suppose if you're going to delete this node, this will become my first node, right? So if this becomes my first node, I want my first pointer to point to this node, right? So I want my first pointer to point to 200. So what I require value here, I want first to be pointing to the address 200, and we're gonna delete this. Then there is one more change which is required. Now since this has become my first node after deleting this, so last node should contain the address of first node. So what I want value here to be 200, right? So there will be basically two changes required. First, this should contain the address of next node since you're deleting this, and the last node should contain the address of now, which is the first node. So how we gonna write the code for this? So let's write a code. Void, I'm writing a function delete underscore first node in case of circular linked list. So now I'm taking only one pointer. Just see if we can do this with the one pointer. If I'm writing struct node star ptr, fine. So I'm writing struct node star ptr. So now I want this ptr to point to the first node initially because I'm going to free the first node. So ptr is equal to first. So therefore the value of ptr is right now 100. Now you think guys, now if you want to delete this, okay, if you delete this, then this becomes your first node, and the first should point to the address of 200, right? And then what you want in the last node, you want the address of this node, second node. So it means that in order to reach to the last node, you want a pointer to point at the address 300. So this address is very important. So first address we have taken pointer ptr, right? Now we will have to take one more pointer and we have to traverse that pointer till the end. So I am taking one more pointer, I am writing cpt is equal to first, and I am traversing that pointer till the end. So while cpt arrow link not equal to first, I have already explained you many times about this, how it's going to work. cpt is equal to cpt arrow link. So after this line, your CPT points to the last node of your circular linked list. So here comes your CPT. Fine. Now you're going to change the link part of the last node to the address of your second node since you're going to delete this. So here what you want 200 here. So how can you get 200? 200 is nothing but link part of your PTR is 200. So what I'm going to do, I'm going to change the link part of CPT arrow link, I'm going to change with PTR arrow link. So now this blocks contain 200. CPT arrow link, you're going to change this with PTR arrow link. So here now 200 comes. So this step is also done. Now last step. What you're going to do? You're going to move the first pointer, right? You want this first pointer to point into the second node. So second node, how are you going to do this? You will write first is equal to PTR arrow link. Since initially your PTR is pointing at 100, so you write 100 arrow link which is 200. So this address 200 is getting assigned to your first pointer. Fine. So now this connection breaks, and first going to make a connection with the address 200. So now this becomes, now you have to delete this. And what is this 100? I have already assigned the value of 100 to first. You're going to delete this. So you will have to write free PTR. Right. So you're going to delete this. Fine. Okay. So next program, what we're going to do, we're going to delete the last node, right? So I am running this. Okay, fine. Now this time I want to delete this. Okay, think logical. Like if I want to delete this node, I want this address. Fine. I want this address. Now if we're gonna delete this, this becomes your last node. Now if this becomes your last node, then the last node link part should contain the address of 400. Sorry, it should contain the address of first node, which is 100. So here I want 100. So it means this address is important because I want to free this address, and also we need a pointer pointing to 200. This is also important. So I will be requiring two pointers. Let's suppose this pointer is my PTR and this pointer is CP. So let's write a code for this. So we're gonna delete void delete last node. So I'm taking two pointers, struct node star PTR comma star CPT. Fine. So I want my PTR initially to point to the last node, right? So I'm writing PTR is equal to first, and while PTR arrow link not equal to first, as I already told you, this is the set code which makes sure that the pointer points to the last node, and you want to increment the pointer. PTR is equal to PTR arrow length. Fine. So now when you write this code makes sure that your pointer points to the last node. You want your pointer pointing at 300. But what we require one more pointer pointing to just the previous node of the last node. So I want a pointer pointing at 200. So now check this, guys. PTR arrow link. PTR arrow link, I am checking the link part of PTR, which is 200. 200 not equals to 100. Your condition is true, and you're gonna move the pointer to PTR is equal to PTR arrow link. So now your PTR moves to what? PTR moves to 200. Right. So now tell me, guys, what is the value of PTR? Tell me what is the value of PTR at this blank space which you are seeing here. What is the value of the PTR at this blank space? See, PTR arrow link. PTR arrow link is 200. It means that PTR is not 200 because I am not writing PTR is equal to PTR arrow link. Had it been PTR is equal to PTR arrow link, then the PTR would have been the value of the PTR would have been 200. But here it is, I am simply writing PTR arrow link. So I am checking the link part of PTR. So PTR arrow link is 200, but the value of PTR is 100 only. So value of PTR changes to 200 only at this place. So at this place, what is the value of PTR? The value of PTR is 100 only. So what I'm going to do? I'm going to write the PTR and I'm going to assign the address of this PTR to a pointer called as CPT, because what I'm writing here is when my PTR points to the second node, this pointer points to the first node. When my pointer points to the third node, this pointer points to second node. Let's see how it is happening. So PTR arrow link is 200. 200 not equals to 100, condition true. CPT is equal to PTR, since the value of PTR is 100. So therefore the value of CPT is 100. In the next line, PTR is equal to PTR arrow link, since the value of PTR is 100. 100 link is 200. You want to assign that 200 to your PTR. Therefore the value of PTR is 200. Now PTR arrow link. 200 arrow link is 300. 300 not equals to 100, condition true. CPT is equal to PTR. What is the value of PTR? 200 is the value of PTR, right? So CPT is equal to PTR means the value of CPT is now 200, and PTR is equal to PTR arrow link, since the value of PTR is 200. 200 arrow link is nothing but 300. Now 300 arrow link is 100. So 100 not equals to 100, condition becomes false, and you will come out of the loop. So at this point of time, your PTR is pointing at 300 and your CPT is pointing at 200. Fine. So now what we have to do? We have to change this address 300 to the address of my first node, and this 200 is nothing but your CPT. So what you're going to write? You're going to write that CPT arrow link is equal to first. So when you write CPT arrow link is equal to first, this address is going to change with 100, and this connection breaks. Now this becomes a separate identity, and you're going to free this because you want to delete the last node, and this is nothing but your PTR. So you will have to write free PTR. Right, guys? So thank you so much. I hope you are liking the content of my channel, and if you think that it's worth and it's effective, so guys, please do like, subscribe, and please share my channel, and don't forget to click on the bell icon. Thank you so much.